Hi, my name is John. Good afternoon. It's about 10:15 or morning. Pretty sure you're probably doing your homework at night. We will be finding the surface area by revolution around either the XY axis using calculus. This is usually reserved for calculus BC students. If you are an AB student, you're welcome to try it, and if you want to take the BC test, I would definitely do arc length and arc surface areas revolving around the x-axis or the y-axis. One of the problems is the reason why this is the BC course is because the math is very tedious, and the first two attempts I made quite a bit of small little errors, just eats me alive. So we're going to try to do this if you can as fast as possible, but with precision. So I'm going to have to slow down a little bit. Okay. The first question is y equals square root of 4 minus x squared. We're going to sweep it from -1 all the way up to +1, and we're going to rotate it about the x-axis. We're going to go over the formulas first and look at the intuition of these formulas if you can a little bit. Okay. The surface area is equal to integral from a to b of 2 pi r times the square root of 1 plus f prime of x squared dx. I don't know if you can see that or not all the way. I'm going to move it over just a little bit for you guys. It's 2 pi r times the square root of 1 plus f prime of x dx or dy. And the radius now, if you revolve it around this way, around the x-axis, you're going to use d-axis. You're going to slice them up this way, up and down, perpendicular to the x-axis, and your radius r becomes your y value. So that's something you should know. If you're going to sweep it, revolve it around the y-axis, you're going to use dy this time, and your radius is going to be in your x. So the r can be x or y depending on how you revolve around things. So these are two important information you should know before you start the problem. Okay. So let's get started with this problem. I'm going to rewrite this function f of x is equal to 4 minus x squared to the 1/2 power. Now I'm going to take the derivative of that because I need to take the derivative here. 2 pi r is the circumference of the circle, basically, as you revolve it. Your radius being either your y direction, if it's revolved around the x-axis, is your y, distance of that function, and then times 1 plus f prime of x squared. That happens to be the arc length. It's not 1 minus like the arc length formula, it's plus. The math turns out to be a plus in this situation. And then we're going to multiply by the thickness, which gives it a little bit of area. We're going to add them all up, which is integrating it. That's how you should look at this intuition. So what's f prime of x? F prime of x, using the power rule, we bring it on down. 2 minus 1 gives it -1/2, same thing as 4 minus x squared to the 1/2 in the denominator, multiplied by the chain rule. Minus x squared, the derivative of minus x squared is going to be -2x. Notice that it cancels with that. So f prime of x is equal to -x all over the square root of 4 minus x squared. And we need to square that because they want it squared. So I'm going to use orange for that. Square the left side, square the right side. And we'll end up with f prime of x squared is equal to, the negatives cancel, you get x squared. The denominator, the square root cancels, so it becomes 4 minus x squared. Remember, these are inverse operations, so they must cancel. We're also going to do 1 plus f prime squared. That's going to be 1 plus x squared all over 4 minus x squared. That's the same thing as 4 minus x squared over 4 minus x squared plus x squared over 4 minus x squared. Common denominator, that's the same thing as 1. The x squares cancel. you end up with 4 over 4 minus x squared. Now, I'm going to use blue for this. I'm going to take the square root of that, which becomes the square root of that. That becomes square root of a over b equals square root of a over the square root of b. So that square root of 4 becomes 2, and square root of 4 minus x squared. So that's that portion right there. We're going to plug into this formula. I'm going to rewrite it really nicely for you. We're going to factor out 2 pi because it's a constant from a to b, sweeping from left to right, negative 1 to 1 of y times, because it's revolving around the x-axis, 2 over the square root of 4 minus x squared dx. Put a little line right there so that we don't cross over. So the surface area becomes 2 pi integration from negative 1 to 1. Y happens to be square root of 4 minus x squared times 2 all over square root of 4 minus x squared dx. Notice that, lucky us, the constant comes outside, becomes 4 pi integral from negative 1 to 1 of dx. The integral of the constant is going to be just, or 1 is just going to be x. Be 4 pi x evaluated from negative 1 to 1. So using the fundamental theorem of calculus, part 1, it's going to be 1 minus negative 1. You notice I factored out 4 pi. You could have done 4 pi 1 times 1 minus 4 pi times negative 1. It's easier to just factor it out this way. Some teachers are actually starting to do it this way too as well. 1 minus negative 1 is 2 times 4 pi is going to be 8 pi. There you go. Notice at the very beginning we manipulated, we did all the work at the very beginning so it becomes easier for us as we do these problems. So let's look at the next problem. 7 minutes has elapsed, we have a little bit of time. Let's write it again. The surface area is equal to 2 pi integral from a to b. Since we're revolving around the x-axis, it's going to be dx times y square root of 1 plus f prime squared. We need to figure out what f prime is first. So let's rewrite the equation. F of x is equal to x to the 1/2, change it from radical form to exponential form, minus 1/3 x to the 3/2. F prime of x is equal to, using that power rule, bring it on down, subtract 1, so it becomes 1 over 2 square root of x minus 1/3 times 3/2, bring it down, and then minus 1, x to the 3/2 minus 2/2 is 1/2. Cancel that. So f prime of x is equal to 1 over 2 root x minus 1/2 x to the 1/2. Now what we're going to do in this situation is we have to square it. Square the left side, square the right side. So f prime of x quantity squared. I'm going to use that little trick that you have a plus b squared is equal to a squared plus 2ab plus b squared. So I'm going to square the first one. 1 over 2 root x times 1 over 2 root x is 1 over 4x minus 1 over 2 root x times 1/2 x to the 1/2. The x roots and the 1/2 powers cancel, becomes negative 1/4 times 2 is negative 2/4, and then square the last term, becomes plus 1 over 4x. Next thing I'm going to do is I'm going to go plus 1 on the left side. Let's use orange this time. So I'm going to add 1 to that, add 1 to that. Before we add 1, I'm going to get common denominators. It's going to be 1 over 4x minus 2x over 4x plus, this is x is in the numerator, so x squared over 4x. And then 1 is the same thing as 4x over 4x. And then we're going to plus that. So that's 1 plus f prime of x squared. Notice that the 4x and the minus 2x, it kind of cancels out, becomes x squared. I'm going to put this up in front, plus 2x plus 1 all over 4x. That's equal to 1 plus f prime squared. Next thing I'm going to do is I'm going to square root it. Let's use a different color. Pink this time, because I want square root of 1 plus f prime squared. Notice here, that's the same thing as x plus 1 squared. So it's going to be square root of the x plus 1 squared is going to be x plus 1 over, and then 2 radical x, because square root of 4 is 2, square root of x is square root of x. And finally, what I'm going to do is I'm going to write down, factor out the 1/2. It's going to be x plus 1 over radical x. Or I could just go 1 over 2x, but I'm going to plug into this equation 2 as well. So the surface area becomes 2 pi, I factored that out from the integral, from 1 to 3, kind of see this, right? 1 to 3 of square root of x minus 1/3 x to the 3/2 times, I'm going to factor out the 1/2 with the 2, that cancels the 2 right here, x plus 1 over square root of x dx. I'm actually going to put it here, that way you know it cancels with this 2. So yeah, pi right here, square root of x times this. Now I'm going to keep this one, same thing as x plus 1 in the numerator. I'm going to distribute this out. Multiply square root of x divided by square root of x minus 1/3 square root of x to the 3/2 divided by square root of x. So pi, integral from 1 to 3, that distributes to a x, and then minus 1/3, and then one of the halves cancel, is going to be x to the 1/2 times x plus 1. Oh, not 1/2, excuse me, 1 dx. And so there it is so far. Pi. It's a little bit tedious on this, so we're going to have to be very careful. 1 to 3, x times, is that right so far? Square root of x times, oh, that's going to be 1, excuse me. Didn't quite seem right. 1, square root of x divided by square root of x divided by square root of x is just 1. Minus 1/3, 1/2 cancels, so it becomes x. Okay, good. We got it right so far. Now I'm going to have to distribute these out. 1, and by forming 1 times x is x, 1 times 1 is plus 1, minus 1/3 x times x is minus 1/3 x squared, minus 1/3 x times 1